3i Atlas has returned with a vengeance after emerging from the Sun's colossal shadow. Take a close look at this astonishing image captured by the Virtual Telescope project in Manciano, Italy on November 11, 2025. A massive electric blue ion tail erupting into space, stretching millions of kilometers as it blazes through the solar wind, marking the third color transformation of this interstellar wanderer. Yes, this time it hasn't just reappeared, it has reinvented itself. How are the world's top scientists explaining this extraordinary phenomenon? This video will take you through the most cutting-edge perspectives on this enigmatic celestial visitor. At this point, you could practically call 3i Atlas a cosmic chameleon, the darling of the astrophysics community. The July infrared observations showed its coma glowing with a reddish tint while it was still around 3.3 AU from the Sun. But around September 7, 2025, the Hubble Space Telescope recorded something unexpected. That signature pink-red hue vanished, replaced by a faint green glow. It's so surprising, right? And yet now, as it approaches perihelion, it has shed its colors once again. It has turned blue itself. And as it rises once more from the dawn horizon, with a colossal ion tail bluer, by the day that makes its transformation impossible to ignore. When the tail image was released, cosmic researchers admitted that it offered a fresh and astonishing perspective on this interstellar object. Yet what we see is not exactly what Gianluca Massi, the photographer of the image, captured at first. After processing 18 separate 120-second exposures, it revealed the ion tail of 3i Atlas with a clarity surpassing anything previously observed, stretching at least 0.7 degrees across the sky, oriented toward the northeast. The anti-tail is clearly visible as well, extending in the opposite direction. This implies that the tail is expected to grow even brighter, longer, and more extended in the days ahead. The observation of 3i Atlas ion tail is not limited to Massi in Manciano alone. Several astronomers around the world have independently confirmed similar structures. Two British amateur astronomers, Michael Buchner and Frank Niebling, photographed the same tail from Spain using their personal telescopes. Niebling commented candidly on his observation, interstellar comet 3i Atlas, on November 9, 2025, shows nice tail structures despite interference from moonlight, which was 82% illuminated. He described the smoking tail captured in his image with admiration. All right, everyone, be honest. Can you see just how unique our third interstellar visitor is in these images? Drop your thoughts in the comments. And don't forget to keep supporting us with your likes and subscriptions. We really appreciate it. Okay, another piece of evidence comes from Austrian amateur astronomer Michael Jaeger, who has been closely monitoring the interstellar visitor since November 4th. Jaeger reported multiple detections of the enormous ion tail and provided even more detailed observations. He noted that a single stream of the tail seemed to branch into 4 or 5 smaller streams. This indicates that the tail's development is not only extraordinary in terms of size and brightness, but also exhibits structural complexity far beyond that of typical comets within the solar system. Fortunately, the ion tail of 3i Atlas is exceptionally bright at present, allowing it to be observed even with ground-based telescopes. These observations provide an invaluable opportunity for scientists to study how an interstellar object interacts with solar forces. By analyzing these interactions, astronomers can gain unique insights into both the physical properties of the comet and the dynamics of the solar wind in ways previously impossible. Moreover, this long, intricately structured tail offers a rare glimpse into how interstellar objects may behave differently from comets born in our solar system. Its branching patterns and striking brightness point to unusual chemistry or activity at work. In many ways, this marks a new era in deep space observation. With each passing night, 3i Atlas unveils more of its hidden mechanics, reminding us just how dynamic and unpredictable the cosmos truly is. After the initial wave of astonishment, NASA scientists quickly began running simulations and analyses to understand the origin of 3i Atlas's magnificent tail. Their goal was to ground this spectacle in the realm of physics, to explain through science what seemed almost supernatural. First, they emphasized what appeared to be normal by cometary standards. The most defining trait of an ion tail is that it always points directly away from the sun. This phenomenon occurs because solar ultraviolet radiation ionizes the gases and molecules released by the comet, stripping them of electrons. These newly charged particles are then swept outward by the solar wind, forming a luminous blue stream that extends for millions of kilometers. In contrast, the dust tail, pale white or yellow, bends gently along the comet's orbital path under the pressure of sunlight. Scientists explain that this stunning image results from a burst of activity on the object combined with intense interactions with the sun's enormous heat. They expect that the ion tail will continue evolving dramatically as 3i Atlas progresses through the inner solar system. In detail, NASA pointed out that this very behavior is what confirms 3i Atlas as a comet. Its tail grows brighter and longer as it approaches the sun, revealing an increasing rate of gas sublimation and plasma interaction. Similar ion tails have been documented in other comets. In 1997, Comet Hale-Bopp exhibited an intense blue plasma tail visible even to the naked eye, while Comet Encke in 2007 showed a dramatic ion tail disconnection event when struck by a burst of solar wind. Now 3i Atlas joins that rare class, a celestial traveler whose glowing ion wake writes new chapters in the story of cosmic evolution. However, every phenomenon has two sides. When a coin is tossed into the air and lands on the ground, we often see only the face turned toward us, while the other remains hidden, waiting to be brought into the light. The same principle applies here. As I mentioned earlier, the ion tail of 3i Atlas has revealed something that sets it apart, elevating it a step above ordinary comets. And the case of this object, that hidden face, lies in the staggering speed of its tail's growth and in the mysterious emergence of its anti-tail. According to recent analyses by Professor Avi Loeb, the renowned astrophysicist at Harvard University, at a distance of roughly 326 million kilometers from Earth, the angular measurements correspond to physical extensions of about 950,000 kilometers for the stream directed toward the sun, and an extraordinary 2.85 million kilometers for the tail stretching away from it. Compared with earlier images, the truth is now undeniable. The tail of 3i Atlas has exploded into a colossal outburst. When the Hubble Space Telescope captured it on July 21, 2025, the coma was visible, but the tail appeared faint and short. Through August and September, astronomers began to notice a subtle curve forming in the tail as it turned away from the sun, yet it remained relatively small, just around 100,000 kilometers in length. Then suddenly, something changed. Even when comparing the images captured in the first half of November 2025, the tail's growth is strikingly rapid, extending from just a few 100,000 kilometers to several million kilometers in only a matter of days. The ion tail of 3i Atlas has now grown far longer and brighter than expected for a newly arrived interstellar visitor. NASA scientists interpret this as a clear sign of an evolving cometary process, a transition from a phase dominated by the release of dust and gas to one where intense ionization takes over, producing a spectacular plasma-driven tail that defies prior expectations. It is a living demonstration of a comet's heartbeat quickening under the sun's fierce radiation. And the other half of this mystery, of course, lies in the astonishing appearance of an anti-tail. Normally, anti-tails are faint transient streaks that appear only when Earth passes through the comet's orbital plane, creating the optical illusion of a tail pointing toward the sun. These are usually formed by larger, heavier dust particles that are less affected by solar wind aligning briefly in our line of sight. But 3I Atlas is rewriting that rulebook. Its anti-tail is anything but faint. Observations from NASA and ESA describe a bright, sharply defined structure extending nearly 1 million kilometers, luminous, persistent, and stable, even as the ion tail surged to its greatest intensity. Such clarity and symmetry between the two opposing tails are almost unheard of in modern astronomy. Both agencies have offered scientific explanations that the comet is ejecting an unusually heavy load of dense dust particles while simultaneously undergoing extreme solar wind interaction. The remarkable coincidence of these two massive opposite-facing tails suggests that 3I Atlas may be experiencing a peak phase of activity, a rare moment when dust plasma and geometry converge perfectly to create one of the most extraordinary cometary displays in history. This alignment of cosmic forces, a blazing ion tail stretching millions of kilometers into space, countered by a radiant anti-tail, reaching back toward the sun, transforms 3I Atlas into more than just an interstellar visitor. It becomes a living canvas painted by sunlight and plasma, an astronomical paradox whose beauty conceals a deeper enigma still waiting to be understood. Undoubtedly, this enormous ion tail is more than a spectacular sight. It is a scientific goldmine, offering an unparalleled glimpse into the dynamics of interstellar objects, their chemical makeup, and the intense forces that govern their behavior. As researchers around the world continue to monitor its evolution, each photograph and observation will deepen our understanding of the solar system's place within the vast, boundless galaxy. That's it for today's video. We'll see you, my dear friends, in the next one.